The fish family. So now we're going to make two more fish. Here we go. That's the one we've already made. Medium-sized piece of paper, but we're going to use a small piece and a large piece to make the whole family. Same every time. Fold in half, get it just in half, fold it. Don't forget you can put your name on it. Do the two little scissor cuts near where the tail is going to be. Halfway on that side, turn it round. Halfway on that side, but near the very back. Wiggle the two scissor cuts together. Squash it a bit to get a proper shape, and that's our small size fish. And now the biggest fish of them all. Here it goes. Same again, fold in half. Oops. Go near the back. We don't have to be so near the back as for the little one, so move back a bit there maybe. Halfway through. Next one is from the other side. Halfway through. Wiggle the two parts together. There we go. Open it out. And there we have our fish family. Absolutely fabulous. So now what we want to do is repeat our experiment where we just use the medium fish first of all. You should have noticed a few things. First of all, it does not fall in a straight line. Normally when you drop a ball, it falls in a perfectly straight line. And that's because everything is pulled down towards the centre of the earth by the special force of gravity. So gravity is pulling everything down towards the earth, and that's why our feet stay on the ground unless we try to jump high and get off the ground, but gravity always pulls us back. So that's our flying fish there. It falls not in a straight line, but normally things do fall in a straight line. So something special about the fish, or perhaps something else, that's making it do something strange. So it's not a straight line. Let's turn it sideways and pretend that's high and that's low there. So as it's falling, it actually moves off to the side one way or the other, but it does something else as well. You should have noticed that it tumbles its way to the ground. So it sort of spins round and round. So it doesn't fall in a straight line. It falls in a path off to the side. It moves away from you or near to you, but it doesn't fall in a straight line. And it spins really rapidly. I think that's why we call them flying fish. Well, what's going to happen if you've got a little fish and a big fish? That'll tell us more. Try the experiment and see if you can tell the difference between the big fish and the little fish, and work out why. Here's the clue. There's not just gravity involved. We know that all around us we have the air that we breathe. So the air that we breathe is a real material. And when the fish try and fall, they're not falling through nothing, they're falling through the air. So the air, if you like, is pushing against them as the fish is trying to push the air out of the way. So the fish starts high up. As it falls, the air that's in the way gets pushed out of the way, and that pushing force of the air itself starts to slow the fish down. Well, if you've only got a very little fish, what's the difference? There's not much air to be pushed out of the way, but there is for a big fish. All of the air pushes against it, slows it down. The little fish doesn't have as much air pushing around it because it's not as big. It falls really quickly, spinning really quickly as it goes, and the biggest fish falls really slowly and spins more slowly as well. And the medium-sized fish, well, he's somewhere in between. So that should be the fastest, that's the next, and that's the slowest. So air and gravity affect things when they fall, when they're released and we let them fall. Fabulous.